Yes, so thank you, Stefan and Frank, for the invitation. Initially, I was going to present the research I've been doing on comparing hardware licenses, and this is a work in progress, so I decided not to present something that is not ready yet. And instead, I decided to present an initiative of many academics who are working either developing open hardware or helping to promote open hardware in the academic context. To answer this question, how to create a culture of hardware sharing in the sciences or in academia in general, there are many ways, as we know, and we were exposed to one of the university program just before my presentation. But one of the potential ways is to start an academic journal, and this is what we decided to do. So when you think about an academic journal that is dedicated to open hardware, you have two different communities, two different audiences to deal with. And then you have to convince what are the benefits of creating an academic journal. So for community projects, how academics can contribute to advance open hardware projects. So we could, for example, help to provide peer review for open hardware documentation. And we can also help create a culture of good documentation around open hardware technologies, and help projects to be indexed in public repositories, and generate, and this is an important point, generate a registry of prior art. When it comes to academics, how do you convince them that it's a good idea to create a journal for open hardware? Well, what you can do is to say that you can publish your open hardware project as a peer-reviewed publication. And that can count, if you're an academic, as a publication. So you create an incentive for academics, in fact, to document the hardware they're producing and to publish it as a peer review publication. So basically, in a nutshell, the idea is to create interfaces between community projects and academic projects. So what we did was to create a journal called Journal of Open Hardware. It was created in a gathering of open hardware developers at CERN in 2016. And it was primarily organized around the idea that we wanted to bring people with different forms of expertise to collaborate in the journal. People who are working in academia, people who are independent engineers working with, as consultants or working for different companies, and also community members, a lot of people who are learning about these technologies, and they help in many ways by documenting, by providing help or bug fixes, so forth and so on. So what we did that I think is interesting about this initiative is that we came up with one particular publication format that is tailored for open hardware projects. And our journal is community controlled. It was a community effort out of this gathering for open science hardware. And it's community controlled in terms of its governance, in terms of its content, in terms of pricing, in terms of platform development as well. And that practically means that we are extremely poor and we're constantly looking for sponsors. So this is the shameless plug part of my talk. And we collaborate with Ubiquity Press, which is an open access platform from the UK. And they host several journals, and they host ours. So what we emphasize is the idea that to have a healthy open hardware project is to fundamentally insist on good documentation. Without good documentation, you don't create the basic conditions for your project to flourish and for your project to be adopted more widely. So what we did was to draw from community-vetted definitions of what counts as open source hardware, and also different best practices for hardware documentation that were also produced by the community. So we have all these documents, and we created a synthesis to help guide the authors who submit papers to our journal. So basically, we combine the classic 4 freedoms that that are the foundation of what we do in free and open source technology in general. You know, the ability to study, to modify, to redistribute, and to use for different needs. But also combining 4 orientations for hardware documentation, which is what we are really focused on. So the idea, we convey this idea that the documentation has to be accessible, it has to be written in a very clear language, and it also has to be open license. We show the authors that they have choices in terms of licensing. But they have to pick the licenses that are the most solid licenses we have available for releasing a piece of hardware, a hardware project. It has to be sufficient. The idea that, as we all know, people who are involved in open hardware, you have to provide the basic conditions for the hardware to be replicated. And this is in the scientific workflow, this is extremely important. We emphasize that. It has to be findable. And this is another question that we emphasize. We don't want a flimsy URL that is going to disappear with the sources. So we try to emphasize the idea that if we can use a long-term repository and if we can attach a persistent identifier to the source, that is extremely useful for us in terms of tracking, for example, provenance. If you are for example, in a context where we have to do with compliance, this is also extremely useful. And the idea of being open in terms of the process and not only the end product. This is also an important message that we convey as we engage with the authors. And we publish in our journal in 4 basic categories. We have this specific tailored publication format that we call a hardware metapaper. And I will give you an example in my next slide. We have a track that is only for studies on the social and economic impact of open hardware technologies. We have a new section that we just started a couple of months ago on educational open hardware projects. And we also do reviews that we consider to be very useful for the community, reviews of open hardware conferences, such as this one, and also books that are coming out on the topic. So what is it's part of the hardware metapaper format. So basically you have an overview. The overview will tell you how that particular piece of hardware fits into a research project, into an academic research project. After that part of the review, we have a very important section that is the section of quality control. What are the safety measures that the researcher applied for that particular project? How do you go about calibrating that particular scientific instrument? And the testing procedure that you have to follow after you completed assembling the scientific instrument. And then you have an example of how to apply that piece of hardware. You have the build details, like a very well detailed step-by-step instruction of how to put together the piece of hardware, and a discussion of what is the hope of the author for creating derivative versions of that particular piece of hardware. And as I said, we insist on persistent identifiers for the hardware and software sources, and for the instructions, for the build instructions. So here's an example of one of the pieces that we published. So this is an example of the hardware metapaper. So this is a device that was built by colleagues at the University of Cambridge in the Department of Zoology. They built this rig for basically feeding these pipettes, the vials, with like food for fruit flies. So this is a very labor-intensive work, and so they basically built this device for helping them in their genetics research. And so what I want for you to pay attention in this piece is that we have this metadata overview. I don't know if you will be able to read because it's a bit small here, but we have there the pointers for everything that you will need in terms of like where the hardware design files are, the software source code, the manual for putting everything together, what the target group is, and there's another section that we also consider interested. It's the skills that are required for actually assembling this particular piece of hardware and how hard that is. So another example that as I said, we just started the section on educational hardware, is the idea that we have a substantial part of the open source hardware community is dedicated to educational efforts. So we decided to have a track that is dedicated for papers demonstrating the hardware development for educational purposes. This is a fascinating piece that came from colleagues at the scientific outreach at CERN, where they developed this particle trap for teaching particle physics for high school students and university students. And again, you have the metadata overview with everything that you need to build this device for the classroom. We also have a track that is, we could say that is underdeveloped, not only for hardware, but also for free software. We don't have many researchers working on understanding the impact, the social and economic impact of free and open source technologies in the world. We need more and more of that. And this is very clear when we stop to talk with people in our circles and conferences such as this, where people will say, well, this type of license is the most prominent type of license that we have in the world today. Well, where are you getting this information from? Where's this actual survey that will back up your information? Is it Black Duck, a survey that was conducted? Where's the actual hard evidence for making claims about a certain a certain license or a particular type of technology? We need more research, empirical research on free and open source development for software and hardware. So we have this particular piece. I find this piece fascinating because the authors, it's a group of authors from different German universities, but the primary author, the first author is at the University of Bath in UK. So instead of going from the licenses to define a particular project, they invert the question that they say, let's look at the licensing practices of everyone who calls their piece of hardware open source. So let's see what licenses they're using. Let's see what they make available. Let's see what's not available. Let's see how they are documenting things or not, how they're releasing things. So they take an empirical approach to understand what is after all, what is the source of open source hardware. So I recommend looking into this. They have 132 products. This is a group of researchers working in industrial settings and trying to understand open source hardware development for the industry. And they analyzed 132 products. They're really interested in the end products. So this is one example of empirical research for the journal. We also have economic studies. We need much more of that as well in open hardware and free software. So this is a piece by a researcher from Michigan Technological University. You probably heard of him or read his articles in different venues. In this particular piece, he is evaluating the business models, emergent business models in open science hardware, like creating businesses around the development of scientific tools that are open source. And as I said, we have conference reviews, such as the first one where the journal came about, the Gathering for Open Science Hardware at CERN in 2016. And we also do book reviews. So if you read a book that is interesting for the open hardware community, you're welcome to submit that to us as well. And this is a review of the book, The Hardware Hacker by Andrew Huang. So basically, in terms of conclusions, I don't have much. My conclusion is actually a call for papers. Again, another shameless plug of mine. We have many ways to promote open hardware in academia, and the way we're doing this is by creating a journal and promoting a journal. And if you know anyone who's developing their own scientific instruments and they want to publish with us, we're open for submissions. And as I said, we publish in these 4 categories: on the hardware metapapers, educational open hardware projects, socioeconomic impact studies, and book and event reviews. So if you have any questions, I'm open to hear what your feedback. Thank you.
So these people sending you links to hardware design files, these are usually what, Gerber files or?
It has to be everything. It has to be the design files, the mechanical files. If you have like a firmware, it has to be the source code for the firmware. It actually has to be everything, the schematics, the net lists, everything that you will need to actually reproduce that piece of hardware. Has to be included. So we make sure to talk to the authors to make sure everything is in place before it's published. Otherwise, other people wouldn't be able to replicate as easily. We don't want people to have to reverse engineer anything before they build like the research instruments. The whole idea is actually to make things as simple as possible for people who on the adoption side. So that's the effort we're making with the journal.
Yes, I think that's a very good idea, and it's in particular the metadata, this
Yes.
part where you require from the authors that they give enough information to be able to replicate their work. It's also in line with open science, of course.
Yes.
And there is this other effort from the Open Source Hardware Association, this certification effort, which also goes in the same direction, right? This is very good because it's things that licensing cannot do anything about. This is beyond the realm of what licensing can enforce, right? So it's very good to have this. My question is, are you in touch with the Open Source Hardware Association, or how compatible is your requirement for metadata with their requirement for certification?
Yes, so we actually use, we are in contact. We have a member of our board who is the director of the Open Source Hardware Foundation Association, Alicia Gibbs. And we actually draw, as I said in this slide here, we actually draw from the community vetted definition. So we use the open source definition that was an effort of many people who were involved in the association. We also use the best hardware documentation practices from the association to guide the authors. And the certification is extremely useful because they already do the work of verifying that all the requirements for open source are in place for a particular piece of hardware. So if it's already certified, it makes our work with the authors easier. So yes, we work closely with the association. We're actually trying to convince them to be the steward for the journal, but they're overstretched, like all of us are in academia, so they couldn't take up the administration of the journal, but we work closely with many of them. Yeah.
Hi, thank you for the presentation and the journal, great work. As one of the motivations that you mentioned is attracting academic contributions.
Yes.
I was wondering, because for the journals, for me as an academic, indexing is very important.
Absolutely.
And I was checking out the indexing. One of them that is for me the most important and is missing is the SCI index.
Yes.
Are you on it? Are you considering it?
Well, we are striving. The reality is that because it's an open access, it's a fairly recent open access publication, it's going to take a little while before we can be indexed. But we understand that it's extremely important for us to be indexed across different indexing services. And we have been insisting with the platform that hosts us, Ubiquity Press, to push for indexing of our journal. So it's in the horizon, and we should be indexed widely as soon as we can. But this is it's a barrier that we face as being like a very young publication and being in the open access space. Even though we have an academic board with academics of different stages of their career, well established and young academics, we have a very good academic board. So we have everything in place to actually push for indexing, and it's going to happen very soon. Yes.
Thanks for your talk. It was quite interesting. So my interest is silicon, and
Yes.
so as you drill down in the requirements of what you must include and everything has to be there, how do you deal with,
that-
our tool chain comments from earlier, libraries?
Yes, well, when it gets to that level, I think we're actually just starting to make inroads into the open silicon debate. Of course, you guys have been there much longer, and you're actually like driving this process very much. We tend to think about what is not open source in terms of what Andrew and Javier call available components. So we actually cannot push openness to that level yet or try to enforce it because it's not realistic, right? So until we get there, and it's going to take a little while, we cannot enforce that requirement. So we have design files and mechanical files and things that people can actually open source. And what cannot be open sourced is the available components exception. And that's how we deal with this.
So you still allow publication, though?
Yeah.
Because you were saying a pretty hard line on, all this has to be there, but obviously it can't.
We wouldn't publish, we wouldn't have open hardware, and we wouldn't publish anything at this point, right? So we have to make this exception and be realistic about what we have and what we can do. But we're pushing into that direction, so eventually we'll be able to enforce on the silicon level as well. We really hope we'll get there. So, well, I know, but. Well, yeah, I'll probably, we will be dead, but.
Okay, let's thank the speaker again.